Greetings and welcome, friends. We've been talking about like parallel lines and coordinate planes and slopes and all sorts of wonderful things. Slope-intercept form, by the way, is y equals mx plus b, where m is the slope. I sometimes label that in green. I think it's a lovely, lovely color. Although I just made that like far worse. That's fine. And then the slope is like our starting point for lines. Like so, or sorry, the y-intercept, the b is the starting point. The slope is the rise over run that we move. There's a slope formula. Am is equal to, actually, no, what, wrong color, Mr. Waddy. What you doing? What you doing? Y2 minus y1 over x2 minus x1. You could also think about that as the rise over the run. Right. So let's take a look at these lines. They asked us to determine which of the lines are parallel and which are perpendicular. So to calculate the slope of, let's start with line A. So slope of A, I find some lattice points, and it looks like that's just going down 1 for its rise. So that's a -1 over 4. So -1/4 is the slope there. All right, we'll use the slope formula on, I think, the next example that I've selected, so we'll wait a minute there. So let's see, lattice points for this one. I could find some of my own, but they had some labeled. There's one like here, and here, and here, and here. And one of the things we talked about yesterday was even if, say, I went and jumped over one of the lattice points, my rise over run will still reduce to being the same fraction as if I did it you know, 2 of the consecutive lattice points. So -2/6 for the slope of B reduces to -1/3, the same as if I went down 1 over 3 right there. Right? Let's see. And C. Oh, little purplish fuchsia thing going there. I don't know. Looks like it's going up 3 and over 1, so slope of C is just 3, or 3 over 1 if you really want, but you don't have to write that. And then the slope of line D, let's see. Oh, I think I actually nailed that color. Look at, oh, that's pretty close, right? Yeah. It is such a gross green. I do agree. Add your comments to the you know, below the YouTube video here if you want to comment on your least favorite of these colors. And then the slope of line D, oh, it looks like there's some multiple lattice points here, I think. Up 3 over 1, up 3 over 1. So, in terms of parallelity, parallel lines have the same slope, so it looks like C is parallel to D because of the same slope. And then in terms of perpendicularity, I like to say their slopes are opposite reciprocals. So C is perpendicular to B, and D is perpendicular. I don't know why I did C and D first. It feels like alphabetic order would have been a better choice. I like the symmetry of this here. Actually, I feel like this could be like some sort of like a meh, like sort of like if I was texting someone and I had a perpendicular symbol, that'd be like a pretty good face. I don't know what that face feels though. Smiley? Is it smiley though? I don't know, or is he so angry that the slopes of his eyebrows became perpendicular, or like, and now they have no slope because perpendicular or vertical lines have no slope. Maybe. Yeah. Well, anyways, these are opposite reciprocals of one another, right? Flip it and change the sign, and you can see that, and man. Wow. Imagine if what if our eyebrows were vertical? Yeah. It'd be like, I think I need to Photoshop that and see what happens. Oh dear. All right. Let's see. I picked example 10 here. Let's keep cruising here. What you doing, Mr. Waddy? Tell whether the lines are parallel, perpendicular, or neither. Let's find the slope of line 1. Yeah, I guess I'll use some colors here. So slope of line 1 will be, yeah, -2 minus 1 over -7 minus a -3. So y2 minus y1 over x2 minus x1. The order does matter, or your slope will be off by its sign. So -3 over -7 plus 3 is -4. So it looks like the slope of line 1 is 3/4. All right, I got some concurrence from the audience here. Ooh. Oh wow, even an applause. That applause is a little bit sarcastic, and it hurts my feelings. I'm just kidding. All right. Let's see. Classic Liam math. No, what you need to do is the slow clap when I get the distance formula right. Like, wow, Mr. Waddy, amazing. You got it right for once. That'd be pretty good. Okay, all right. 4 minus -1 is 5 over 8 minus 2 is 6, which is my least favorite number. Have I told you guys that yet? 5/6. Because you have to pluralize sixth. Sixths. Ugh. And it's my least favorite number because 1/6 is a singular number of sixths. 2/6 you would just reduce to 1/3, or yeah, and 3/6 is just 1/2, so you wouldn't have to say it. 4/6 is 2/3, but 5/6, ugh, literally, it's my least favorite number in the universe. So it's awful. It's awful. So looking at these, it looks as though these are neither. All right, let's get to the real problem here. All right, here I've got question 16. All right, it says, write an equation of the line passing through point P that is parallel to the given line. Oh, what? Graph the equations? Oh dear, I didn't give you a graph, so you guys, you could have skipped that part. But I'll throw a graph on the screen for funsies, though, don't you worry. Let's see. So first thing, here's the equation of that line, and that is in what's called standard form. Actually, it doesn't even meet the standard form for some textbooks. But I'm going to solve this equation for y to put it in slope-intercept form so that I can determine its slope. And why would I care about the slope of this line? Yes, because a line that is parallel to it is going to have the same slope. Divide everybody by 2, and y is equal to 1/2. Notice that instead of writing x over 2, I actually pulled like the invisible 1 coefficient out front, and I like to write this as a coefficient of the fraction as a coefficient of the x term, so that way it's more obviously the slope to me. So the slope of line 1 is that 1/2, and the slope of our line is also 1/2. So we are halfway to solving the mystery of what our line must be. Now I've got to find my line's y-intercept, and the other line's y-intercept was this +6, but mine's not going to be the same as that one if it's parallel. It wouldn't make sense. Those would be coincident lines if that was the case. And so what we talked about was you'll take y equals mx plus b. Is this, which method did you guys like using more? Was it y equals mx plus b or point? Okay, all right. I'm getting a nod on the y equals mx plus b. So we'll use that version. And what I'm going to do is plug, this is an ordered pair that will make my equation true, right? It'll make the equality true. So I'm going to plug this as a combination of x and y that makes it true. I'm going to plug in this for m, and I'm going to solve for b. Bless you, bless you. So let's plug and chug. 0 is equal to 1/2 of 4 plus bravo. There we go. So 0 equals half of 4 is 2 plus b. Subtract dose from both sides. And it looks like I get b is equal to -2 when I symmetric property flip it. So the equation of our line is y equals 1/2 x minus 2, right? And notice when I write it, I only plug in the b and the m. I am not plugging in the point because I want y and x to be written in their most generic form, so that I can, kind of like have it represent all possible combinations of x and y that make that equation true. Let's see, I'm just scrolling looking for a coordinate plane. Man, seriously, that would be like the best intro line for like a rap song. I'm just scrolling looking for a coordinate plane. All right, we'll have someone, oh no, I don't have room because I pre-planned another problem here. Let's see, can I fit my graph here? You guys didn't have to graph last night, I realize. But maybe future generations will, so I'm going to represent them. So let's see, y equals 1/2 x plus 6. I would start at 6 for the first line, and the slope was 1/2, so I'd go up 1 and over 2, and up 1 and over 2, and up 1 and over 2. You could also go down 1 and backwards 2, right? And let's graph that line. Ooh, look at this straight edge that I've got. Yep. All right, I think I'll make this line blue. Right there. So there's the line they gave us. Now the point they gave us was at over 4 up 0. And so I think we can all visualize what this line will look like, something like that. But let's verify it by graphing our equation. So y intercept is at -2. And then we would go up 1 and over 2 and up 1. Oh, you sunk my battleship. Direct hit. Right, there we go. So let's see. And watch this. I like this. I already have my line on my straight edge. And oh, ding. Look at that. It's like they're parallel or something. Wow, I love it. I love it. All right, so seems verified. Whoa, I'm getting, man, whew. Excitement here. People are believing it. People believe that parallel lines have the same slope. A believer, is that what you said, or a believer? Okay, all right. Feel free to add a comment to a Justin Bieber video in my channel. I would appreciate that. So let's see. Is the quadrilateral cursed a parallelogram? Explain your reasoning. So right now we might not even have a definition of parallelogram. I haven't given you one, but maybe you have one from your middle school days. Let's see. Yeah, I'll use green and red for my colors. So basically, a parallelogram is a quadrilateral that has opposite sides, both pairs of opposite sides parallel. So that's what I've got to determine, and I could show that by notice that the slope here is up 3 over 1. Right, and the slope here is up 3 and over 1. So those lines are parallel. Ba-bam. And let's check the t'other ones. So are these parallel lines? And it looks like this is going down 2 and over 4. This goes down 2 over 4. You could have also reduced -2/4 to -1/2. And notice that that does also land on a lattice point. So those are parallel. I just realized, yeah, by the arrows that I drew, it looked like these are labeled double arrows. So I'll label these red ones with single arrows. So since the opposite sides are parallel, yes, I'll just say op sides parallel. Bam. All right, drop the pen. Have a great day, internet friend.